Hi, this is Dr. Mervin, and in this video we are going to see how to carry out a hypothesis test. So let's begin by learning types of hypothesis, rejection and non-rejection regions, types of errors, tails of a test. So what are the types of hypothesis? Null hypothesis. It is a claim or statement about a population parameter that is assumed to be true until it is declared false. Alternate hypothesis. It is a claim about a population parameter that will be true if the null hypothesis is false. Next, rejection and non-rejection regions. If we plot level of evidence for rejection of the null hypothesis along the x-axis, then there will be a point C which is called the critical point, which will determine whether we reject or accept the null hypothesis. So the region left of the critical point is called the non-rejection region. So the region right of the critical point is called the rejection region. The left non-rejection region means that there is not enough evidence to declare the assumption is true, and hence the null hypothesis is not rejected in this region. Rejection region means there is enough evidence to declare the assumption is true, and hence the null hypothesis is rejected in this region. Next, types of errors. There are two types of errors. So let's learn about them. So let us cross-tabulate the actual situation versus the decision made on the hypothesis. Actual situation can have two situations. That is, the null hypothesis is true, or in the actual situation, the null hypothesis is false. Similarly, there can be two decisions on the null hypothesis. The first one is we do not reject the null hypothesis. The second one is we reject the null hypothesis. In this cross-tabulation, we can have two correct decisions. The first one is when in the actual situation, the null hypothesis is true, and in the decision, we make it as do not reject the null hypothesis. The second one is when in the actual situation, we say the null hypothesis is false and the decision is reject the null hypothesis. There can be two erroneous situations also. The first one is when in the actual situation the null hypothesis is true and in the decision we reject the null hypothesis. This is called as type 1 or alpha error. The second one is when in the actual situation the null hypothesis is false and in the decision we do not reject the null hypothesis. This is called as type 2 or beta error. So there are two types of error. The first one is type 1 or alpha error and the second one is type 2 or beta error. Let's see them in detail. Type 1 error. As shown previously in the cross-tabulation, it occurs when a true null hypothesis is rejected. The value of alpha represents the probability of committing this type of error. In notations, we can put it as alpha is equal to P of H naught is rejected when H naught is true, where H naught is the null hypothesis. The value of alpha represents the significance level of the test. As previously shown in the cross-tabulation, type 2 error occurs when a false null hypothesis is not rejected. The value of beta represents the probability of committing a type 2 error. In notations, we can put beta is equal to P of H naught is not rejected when H naught is false. The value of 1 minus beta is called the power of the test. It represents the probability of not making a type 2 error. The next one is tails of a test. A two-tailed test has rejection regions in both the tails. A left-tailed test has the rejection region in the left tail. A right-tailed test has the rejection region in the right tail. So, based on the tails of a test, there are three types of tests. A two-tailed test, a left-tailed test, and a right-tailed test. So, how do you identify which tail test it is? This is determined by the sign in the alternative hypothesis. If the alternative hypothesis has a not equal to sign, it is a two-tailed test. So if we have a normal curve and the mean is at the center, then we will have two critical points, C1 and C2. One will be in the left tail. For example, in this diagram, C1 is in the left tail while C2 is in the right tail. The region between the two critical points, that is C1 and C2, is called the non-rejection region. So if your calculated value lies within this region, we do not reject the null hypothesis. The regions left of C1 and the right of C2 are called as rejection regions. So if your calculated value lies within this region, then we reject the null hypothesis. The green shaded region in the left tail, that is to the left of C1, has an area of alpha by 2, and the green shaded region in the right tail, that is to the right of C2, has an area of alpha by 2, where alpha is the significance level. When the alternative hypothesis has a less than sign, the test is always left-tailed. So if we have a normal curve with mean as the center, then in the left tail we will have a point C, which is called the critical value. So the region right of the C value is the non-rejection region. The region to the left of the C value is called the rejection region. The green shaded region to the left of the C in the left tail has an area of alpha. When the alternative hypothesis has a greater than sign, the test is always right-tailed. So if we have a normal curve with mean at the center, then there will be a point C, which is the critical value in the right tail. The left region to the critical value is called the non-rejection region. The region to the right of the critical value is called the rejection region. The green shaded region to the right of the critical value has an area of alpha. So, the two-tail test, the left-tail test, the right-tail test can be easily identified with the sign in the alternative hypothesis. But we can also use the sign in the null hypothesis and the rejection region to identify the tails of the test. So, in this table, we will put the sign in the null hypothesis and the sign in the alternative hypothesis and the rejection region areas and compare it with the two-tail test, left-tail test and right-tail test. So for a two-tail test, the sign in the null hypothesis will be equal to. The sign in the alternate hypothesis will be not equal to. And the rejection region will be in both the tails. For a left tail test, the sign in the null hypothesis is equal to or greater than or equal to. The sign in the alternate hypothesis will be less than. The rejection region will be in the left tail. For a right tail test, the sign in the null hypothesis will be equal to or less than equal to. Sign in the alternative hypothesis will be greater than. The rejection region will be in the right tail. So this table helps us understand by the sign in the null hypothesis or the alternate hypothesis or the rejection regions whether the test is a two-tail test, left tail test or a right tail test. Next, we see the steps to perform a test of hypothesis with predetermined significance level. The first step is to state the null and alternative hypothesis for our problem. Next, we select the distribution to use for our problem. Next, from the null hypothesis and alternate hypothesis for our problem, we identify whether it is a two-tail test, a left-tail test or a right-tail test. And we calculate the critical value and identify the rejection and non-rejection regions. Next, for the given problem, we calculate the test statistic. Then, based on the test statistic value and whether it is in the rejection region or non-rejection region for the null hypothesis, we arrive at a decision. This is an elegant way of carrying out the hypothesis test. So, I hope you understand the steps involved in carrying out the hypothesis test. So, if you like this video, please like and subscribe to this video. Thank you.